Polar coordinates. Polar coordinates are going to be another set of ordered pairs, and your calculators, most graphic calculators, do have a polar mode where you can actually put formulas in written in polar form, and these graphs end up being like interesting looking, flower shapes and circles and things like that. You're not going to be as, I'm going to kind of demonstrate that a little bit and how that's done, but you're not going to be responsible for doing entire graphs in polar form. You are going to be responsible for being able to, identify where a point may be in polar form and convert from polar form to a standard rectangular or Cartesian ordered pair and vice versa. So how do you plot on a polar coordinate system? First of all, notice it looks a little different. It's a circular type pattern. And you have the angles marked, and it's typically, the angles that are marked are typically your special angles that you're supposed to know the sine, cosines, and tangents for. This is what we focus our attention on. They also have, a bunch of circles, and those help identify the radii. So what I'm going to do for this, I'm going to scale this where, if I move 3 circles out each time, that's going to represent a radius of 1. So, for instance here, if I want to plot the polar coordinate 2 comma pi over 4. Now we're used to, when we're plotting points, we would start with the x, we would move left or right, however many units it tells me to, and then from there move up or down from that point to get to where the point should be. Here I'm going to start with the angle measurement. I'm going to find where pi over 4 would be located. So pi over 4 points in that direction. Notice I do extend the line throughout the entire circle, because basically the arrow is pointing in the positive direction, the end is in the negative direction. So if I say, okay, 2 comma pi over 4, I'm going to point in pi over 4, and I'm going to move out 2 radii, and that's where 2 comma pi over 4 would be located in polar coordinates. If I want to do negative 3 comma pi over 3, again I'm going to locate where pi over 3 is. So pi over 3 would be up here, pointing in that direction. Now again, the arrowhead indicates the positive direction, the end of the arrow indicates the negative direction. So, I'm going to want to move 3 units out, right along this circle right here. If I could make sure it's located in the right area, right here. But I want to make sure I'm moving 3 in the opposite direction of the positive. So this would be ground 0, so I'm going to move 3 this way. And try to make sure I line that up properly. So you can see that's why I'm down here for B, because I'm still at a radius of 3, but it's heading in the negative direction. So and the negative direction is going to depend on where you're pointing, when you find that angle. Negative 5 pi over 6. Now these angles are labeled going in that standard counterclockwise direction. I have to recognize that negative 5 pi over 6 for that second coordinate in C would be in the same place that 7 pi over 6 would be. Those are coterminal angles. So where 7 pi over 6 is on the graph, that's where negative 5 pi over 6 would also be, and that's the positive direction. This says 4, so I'm going to move 4 radii out in that direction, so that's where C would be. And of course, negative 1 comma negative pi. Well, negative pi would put me over here. A positive 1 would put me over here. And that's where those 4 points would be.